I am very happy to be able to take part on this occasion when all his friends have gathered to honor KRS70 on his 70th birthday. Well, my mind goes back when he came for the first time to the Indian Institute of Science to join the Masters in Engineering degree course at the Institute. He had got his bachelor's degree and was a top student in his class, not just in his college, but actually not even just in his university, but he was the top student in all the 3 universities the state had at that time combined. This was exceptional performance, and for this excellence he got 4 awards, one of which actually made him an honorary graduate member of the Institution of Engineers in India. When he joined the Institute in 1970, he won a J.R.D. Tata Fellowship and was again the top student in the ME degree. For that degree, he did a project on the Boltzmann equation, showing his great interest in statistical mechanics, which became, in later years, was something which was very close to his heart and led to a series of papers on a variety of subjects. I was very happy when he chose to stay at the Institute, and I and my colleague, Professor S.M. Deshpande, who is the country's leading expert in computational fluid dynamics and a distinguished research scientist himself, we told him that if he were not quite sure what he was going to do, might be the Boltzmann equation, might be relaminarization, he could start on both and could take a decision later. We were following that old rule which says that you have an exceptionally brilliant student, you really give him more than one problem. And Srinivasan was just that kind of student we had. He started on both, but fairly shortly after that, maybe in some 6 months, he began to get very interesting results on the analysis that he had embarked on the relaminarization of turbulent boundary layers subjected to large favorable pressure gradients. And he wrote a thesis on the subject in 1975. And once again, that thesis won for him a richly deserved award at the Indian Institute of Science as the best in the engineering faculty that year. Around that time, there were 4 papers which came out of his work, and there were at least 4 more which came in much later years over the next decade, all of which could be traced to his stay in Bangalore during those 5 years. Srinivasan's interests, as you can see from what I've said, even when he was a student, covered a very wide range. In fact, I think even as he was a student, he knew what all the other students were doing, and quite often they would go to him to ask for his comments and advice, because he was one person among them who actually was interested in everything that was going on. I remember that around that time, the Concorde was asking the government of India to give it permission to fly across land on the London-Perth route. And the government at that time had no experts on the sonic boom problem, and asked me if I could prepare a report for them for the very generous sum of rupees 1,000, which at today's exchange rates would amount to $15. Well, it was a small sum even by Indian standards of that date. But anyway, it looked like a very interesting problem. And Srinivasan agreed to work on the project, and we started on that. And at the end of that project, we had several reports, much appreciated actually, but never published, including an important result which showed that in the tropical atmosphere that India has most of the time, the intensity of the boom could actually be higher than it was in temperate latitudes. We actually went on to measure the strength of the sonic boom when the Concorde flew over India. We traveled about 400 kilometers from Bangalore, set up a station in a small town called Melur with a team of engineers from the National Aerospace Laboratories, also in Bangalore, and measured the strength of the boom that Concorde made. And our calculations turned out to be right. They were bigger than what they had been at higher latitudes. Well, that's only one example. I can quote many other examples where Srinivasan did many other kinds of things. This thesis was followed by many other related studies on problems like the rapid distortion of turbulence, anisotropic turbulence. The homogeneous isotropic turbulence problem had been solved in close form by Batchelor and Proudman much earlier. Initial turbulent boundary layers subjected to such distortion, and plane waves subjected to certain pressure gradients. All of these gave us interesting results. And even after he left for Australia, after his work, he worked with Bob Antonio there for some years as a postdoc. We maintained links and kept writing papers together. There was a comprehensive review of relaminarizing flows in 1979 on the approach of turbulent wakes to equilibrium when perturbed by a favorable pressure gradient. That was in 1981. And zero crossings in turbulent signals in 1983, and turbulence manipulation for increasing drag in 1988, which was 18 years after he joined the Institute of Science. So we had a collaboration program of some kind, even though we were separated by half the diameter of the Earth by that time. Half the circumference, I'm sorry. And there were some others on other related subjects as well. And he was very quick on the uptake. And I remember one afternoon in a casual chat with him saying that there might be some virtue in using Hilbert's transform for analyzing turbulent signals of the kind we had looked at for our rapid distortion work. And an excellent paper by him appeared in JFM a few years later. So frequent visits to his home country and my own visits to the United States and correspondence helped maintain close links for about a dozen years after he went abroad. By the 90s, his and our interests had slowly changed. They briefly touched each other on the role of dynamical systems. But Srinivasan went much deeper into chaos and fractals and wrote a very widely read paper in JFM in 1986 on fractals. At Bangalore, we slowly shifted towards atmospheric boundary layers in the Indian tropics. Well, atmospheric boundary layers to me seem to provide a poor man's device of measuring high Reynolds number flows. But it also had the attraction that we were living in the tropics, and it was a problem of great interest to Indian meteorologists. In any case, we got some interesting results there about tropical boundary layers. And later on moved to the dynamics of cumulus clouds. While KRS had much larger scales in mind. and much smaller scales as well. So he spread out in both directions. Over the years, he has worked on cryogenic problems, turbulent convection, flow at ultra-high Reynolds and Rayleigh numbers, cryogenic convection, cosmic turbulence and electromagnetic fields, and quantum turbulence in more recent years. I cannot think of anybody in the world who has looked at turbulence in such diverse situations, from incompressible flows on flat plates and in ducts to very compressible flows on cosmic scales, with a whole variety of situations in between, both classical and quantum. I have here a few pictures of Srinivasan in India, but unfortunately I don't have some of the pictures that we took during his earliest years at the Institute, for the simple reason that I've not been able to trace them, although they're there, and those pictures, those images are in fact preserved. Sorry. Well, here he is on one of his visits, and that was a good occasion to get both of us photographed. And here he is at a meeting. I believe this was a meeting which was probably organized on the occasion of my own 60th birthday. And you can see, some of you can recognize people here. On the third row, on the front row, there is Fazle Hussain with a sheaf of papers on his knees. There is Hiroshi Sato behind him, 2 rows, in the row immediately behind him, with spectacles looking at the screen, and his wife next to him. There is KRS70 Symposium in the first row. But in this other block, right next to him is my wife. Here is another group of people. At the left extreme are 2 Australians, Paul Gostaloff and Sam Luxton. Sam Luxton had visited us once or twice at Bangalore. And behind Sam Luxton is Badri, who has something open in his arms, a colleague of mine at the Institute. We sort of work together on a variety of problems. Next to him is Vinod Modi, who is British Columbia. And there will be others that Srinivasan will recognize on this picture. Well, here is an occasion when I had moved to the Jawaharlal Nehru Center for Scientific Research after my stay in the Indian Institute of Science. And we finally got a building for the EMU, Electro Engineering Mechanics Unit. And here we are in the traditional Indian style, inaugurating the use of that building. You will recognize Srinivasan is in the middle. And at the other extreme is Professor C.N.R. Rao, who was the moving spirit behind the establishment of that system on the occasion of Jawaharlal Nehru's birthday centenary. Well, so Srinivasan started with thinking about working with the group that was slowly building up at JNC now. And his presence on that occasion was an indication of his continued desire to work with our group in Bangalore. Here he is on one of those occasions at meetings, giving a talk, very happy with what he's saying. And here is another one where he's acting as a chairman. I think this was a meeting which we called Fluids Days. Soon after we moved to the building, we wanted to announce our presence, and we had people from all over the world at that meeting, and Srinivasan here is chairing a session of that meeting. And finally, he's here. I think the third man, the one to the right of my right, is a journalist who wanted to interview Srinivasan, whatever comments he had on Indian science or Western science. And so he were together, I think, after that interview. Now, one thing about keeping in touch with Srinivasan, as far as I'm concerned, was that we depended on his periodical visits to India. Well, every time when we could manage it, we had him for a seminar or a colloquium at some place or the other in Bangalore, maybe the Nehru Center, maybe the Indian Institute of Science, maybe after a while the International Center for Theoretical Physics, which is a part of the Tata Institute of Fundamental Research, which is also now in Bangalore. And he has been on their management boards and has helped them a great deal as they grew. So, I'm sorry that I'm not there in Denver. I no longer travel long distances, and the definition of long distances is shrinking with time. At first I said I'd not go abroad. Then I had to say even Delhi is too far away. And unfortunately, the last time Srinivasan was here, I wasn't up to going and meeting him, at his birthplace. But I'm grateful to the organizers of this meeting for having given me this opportunity to give these few thoughts about him. Well, the thing I learned from his seminars was that every time he came, he seemed to speak about a different subject. So there was some new interest that attracted him. And so I always wonder what he's going to talk about the next time he's in Bangalore. And maybe he's also thinking about what his next area of interest should be in this wonderful picture, in this very characteristic picture. I want to close by a brief message that I sent to his school in a little village, not too far from Bangalore. And it says this, the message, I read it. See how the boy from your school and your village has become a star in the world of fluid dynamics. From how water flows in a channel or a pipe. Now I have to remind you that this is not a trivial problem. Nobody has actually been able to completely figure it out even now. From what happens to a flow in a pipe, all the way to how those gaseous, huge mega clouds in the universe keep wandering in beautifully turbulent ways. There's a huge range of fluid flow problems, from the pipe to the cosmos, and they've all been the subject of Srinivasan's research. I frankly don't know of anybody else in the world today who has touched both ends of that huge range and so many things in between with such mastery. All the best to you, Srinivasan, and more laurels in the coming years. And before I end, I want to take the opportunity to thank my colleague at the Institute of Science, Professor Rahul Pandit, for helping me by taking this presentation with him in a little pen drive all the way across to Denver and making it possible for me to make this presentation. He's speaking here at JNC in a session chaired by KRS70 Symposium. Thank you all very much.